Good day everyone. Welcome to my channel SatMath. I am your SatMath guru with Prakash Singh. Today we are going to learn about numbers and operations. This is the first of many videos in this topic. We are going to understand the types of numbers and study about them with few examples. The first type of number is natural number. Natural numbers are 1, 2, 3, 4. That is, they start from 1 and go up to infinity. The whole numbers are also natural numbers, but they have one extra number, that is 0. That is, the whole number starts from 0 and up to infinity. They go up to infinity. So the only difference between a natural number and whole number is that of a 0. 0 is a whole number, but it is not a natural number. So the collection of numbers from 0 to infinity is called a whole number, while the collection of numbers from 1 to infinity is called natural numbers. Moving on the basis of this, we can answer these few simple questions that are all natural numbers also whole numbers? Yes, all natural numbers are also whole numbers because natural numbers starts from 1 and go up to infinity, while whole numbers starts from 0 and they go up to infinity. That answers our second question, that are all whole numbers also natural numbers? No, they are not natural numbers. Which is the greatest whole number? Obviously, we can't define the greatest whole numbers. We just say that the greatest whole number is infinity. This is a number line representing whole numbers. On this number line, the number on the farthest left is treated as the smallest number, and the number on the farthest right is treated as the greatest number. So whenever on a number line we move towards the right, the farthest right number is the greatest number, and when we move towards the left, the farthest left number is the smallest number. Moving on, the next type of number is integers. During whole number and natural number, we studied that they start from 0 and go up to infinity. That is, all these numbers are positive numbers, right? So there are not only positive numbers, there are also negative numbers too. For example, -5, -1001. These are negative numbers. So the collection of negative numbers as well as positive numbers is called integers. Integers are denoted by the English capital letter Z. Z comes from a German word zählen, which means to count. So integers start from -infinity to +infinity. That is their range. Next in the line is rational numbers. Any number R can be called a rational number if it can be represented in the form of P by Q, where P and Q are integers, right? They belong to Z. So the only condition is that Q cannot be equals to 0. That is why there is the definition. A number R is called a rational number if it can be written in the P by Q form, and where P and Q are integers and Q cannot be equals to 0. Notice that all the integers, positive or negative, can be written as integers. For example, -25. This is an integer. It can be written as a rational number by just putting 1 as a denominator. So -25 is P and 1 is Q. So all the integers can be written as rational number by just putting 1 as a denominator. All the rational numbers are not unique representations of themselves. They can be represented by multiple other rational numbers. For example, 1 by 2. 1 by 2 can be represented as 2 by 4, 10 by 20, 25 by 50, 47 by 94, which all of these on simplification become equal to 1 by 2. So these numbers that are equal to each other, these rational numbers that are equal to each other, are called equivalent rational numbers or equivalent fractions. Representing a rational number p by q on a number line, we have to use the most simplified form of the rational number. That is, p and q cannot have any other factor other than 1 in common between them. That is, in other words, you can say that p and q should be co-prime numbers. Only then they can be represented on a number line. For example, if you want to represent 10 by 20 on a number line, what we'll have to do is, first of all, if you see a number like this and that has a common factor other than 1 common in between them, in this case 2 is a common factor that is common in between them, then we'll have to simplify it first. Or in this case 2 is a common factor, 5 is a common factor, and then 10 is a common factor for both of them. So on simplification this becomes 1 by 2. Only on simplification the rational number that we get can be represented on a number line, that is not 10 by 20 but 1 by 2 can be represented on a number line. Also, that is, first you have to mark 0, then you have to mark 1, and the midpoint of 0 and 1 is 1 by 2. There are also various other ways to represent rational number on a number line, where you have to use some complex rational numbers. For example, if you want to represent 3 by 4 on a number line, then you will have to divide this 1 unit from 0 to 1 into 4 parts, and then the third part, that is 1, 2 and 3, this part is, this section signifies the number 3 by 4. So there are other more various techniques to represent other rational numbers. We don't have to learn about them yet. Now to revise certain concept, let's answer some questions. Is every whole number a natural number? No. 0 is a whole number, but it is not a natural number. It's not a natural number. So this statement is false. Are every integer a rational number? Yes, every integer can be represented as a rational number. For example, if there is an integer, let's say m, then it can be represented as m by 1. So if it is a positive integer, it can be represented as m by 1. If it is a negative integer, it can be represented as minus m by 1. Right? Now the next question is, every rational number is an integer? No, this is not true. 3 by 5 is a rational number, but it is not an integer, because integers are either positive or negative whole numbers, and they are not in fractional form. Moving on, these are the answers to the questions. You may try to note down. Next are irrational numbers. Any number that cannot be represented as a rational number is called an irrational number. That's a simple fact. That is, they cannot be represented in p by q form, where p and q are integers and q cannot be equals to 0. For example, all the roots of numbers which are not perfect squares are rational numbers. For example, root 2, root 3, root 5, root 7. But remember, root 4 is a rational number. Why? Because it is a perfect square and it is equivalent to 2. And 2 is a rational number. It can be represented as a rational number in p by q form. Now pi is also a rational number. Pi is a non-terminating, non-recurring decimal, and it is also a irrational number. Also, all non-terminating, non-recurring decimal numbers are irrational numbers. For example, this number. Here you can see this is a non-terminating number, that is, it is never going to end, and also it is non-recurring, that is, it is not repeating itself. I will give you an example of a recurring decimal, that is 0.333333333. This is a recurring decimal. So we don't want this kind of number. We want all the numbers that are non-terminating and also non-recurring, that is, they are not repeating themselves. For example, 0.1011011101110, this is a irrational number. Now all the numbers that we have studied till now, that is natural number, whole number, integer, rational numbers, all and irrational numbers, all of them, if we put them together in a bag, that bag can be called a bag of real numbers. So real number is a collection of all the rational and irrational number together, and they are denoted by the capital letter R. Therefore a real number is either rational or irrational. So whenever we try to represent any of these numbers, rational or irrational number, they all can be represented by unique points on number line. All of the rational or irrational numbers can be represented by their own unique point. That is why a number line is also called a real number line, right? So a number line is also known as real number line because all the rational numbers and irrational number can be written on it. So that's it for today. Now we are going to study about the complex numbers as well, and imaginary numbers in the next video. For today, that's it, and please like and subscribe my channel to get daily lesson updates, and stay tuned for my next lesson. Thank you. Have a nice day.